So today's lesson is going to be on taking our concept of electron configuration and applying it to an ion. So we're going to be using the electron configuration for ions worksheet on our website. Let's start with looking at the electron configuration for nitrogen in its neutral form. So here's nitrogen in its neutral form. We have 1s2, 2s2, 2p3. So 1s2, 2s2, 2p3. Now, the goal is for our octet rule to be fulfilled. So we have two options. We can either lose or gain electrons to make that happen. How many valence electrons does nitrogen have? Our valence electrons are the outermost energy level, which in this case is the second energy level. It has 5 valence electrons. Nitrogen can either lose those 5 or they can gain, if I have 5 and I need 8, 3. So I can lose 5, gain 3. Ultimately, we learned that ions are going to always go with what is energetically more favorable. So 3 is less than 5, so it's energetically more favorable to gain 3. So if I have 3 electrons in the p, remember the p orbital can hold a maximum of 6. So there's an open space here for 3 additional electrons. Let me show you what I mean here. If we were to draw out our orbital notation, our 1s and 2s are filled. Our p is half filled. So nitrogen is going to gain 3. There happens to be a spot for each of those 3 electrons. Each orbital will now add 1. So if I start with 3 and I gain 3, that's going to give me overall 6 in the p. The s stays the same for the 1. The 2s stays the same, but the 2p becomes a 6. All right, so what has the electron configuration 1s2, 2s2, 2p6? And when we look here at our periodic table, we see that our 1s2, our 2s2, and then our 2p6 is neon. So we would say that nitride is isoelectronic with neon, meaning they share the same electron configuration. Now, nitride is still going to have the same number of protons, 7. It's not neon. It simply has the same number of electrons as neon, and therefore that's what we mean by isoelectronic, and that's what we mean when we're talking about that. It is stable. And if you remember, our noble gases are inert gases. They do not react because they are stable. So this nitride is now becoming stable. Let's look at potassium. Potassium ends in the 4s1. So my electron configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. And if you need a review on how to do electron configuration, you need to go back and watch my video on explaining exactly what electron configuration is and how to complete this. All right, potassium, what is its valence electrons? 4 is the highest energy level. So it has 1 valence electron. Again, we have 2 options, lose or gain. Potassium can lose 1 valence electron, or it can gain 7. 1 is less than 7, so it's going to lose 1. And if potassium loses that valence electron, what am I left with? This electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6. Now, what is potassium isoelectronic with? What ends in 3p6? Argon ends in 3p6. So potassium is isoelectronic with argon, meaning that they have the same number of electrons and the same electron configuration. They are both stable. Let's look at lithium. Lithium ends in 2s1. 1s2, 2s1. Lithium can lose 1 or gain 7. Losing 1 is more appropriate or more energetically favorable. So when we lose 1, we are left with the electron configuration 1s2. What has the electron configuration 1s2? And that is helium. So it is isoelectronic with helium. Now remember, your first energy level can hold 2 electrons. So this first energy level has reached its maximum number of electrons. So it is still a stable cation in the lithium cation. And helium is also stable in its form, okay, because the first energy level can only hold 1. Bromine. Bromine ends in 4p5. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. So bromine in its neutral form has this electron configuration. What are my valence electrons? 4 is the highest energy level. 5 plus 2 is 7. Bromine can lose 7 or gain 1. It is more energetically favorable to gain 1. So we're going to gain 1, making this 4p6. So overall, my electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. So bromide, that's the ion form of bromine. Bromide now ends in 4p6, making it, if it gains 1 electron, isoelectronic with krypton.